Let's talk about exponential expressions. Say we have a number x, which is a real number, and an integer on the right-hand corner of x. We'll call the integer the exponent, and x is called the base. Together, they are called an exponential expression. The exponent n tells us how many times to multiply the base x by itself. Let's do an example. Say we have 3 squared, or 3 to the second power. 3 squared is equal to 3 times 3. The exponent 2 tells us to multiply 3 by itself 2 times. 3 times 3 is equal to 9. Let's do another example. Say we have negative 3 to the second power. The exponent 2 tells us to multiply negative 3 by itself 2 times. Negative 3 times negative 3 is equal to 9. Now the third example is a little different because it doesn't contain the parentheses around the negative 3. So this is negative 3 squared. In this case, the exponent 2 tells us to multiply 3 by itself 2 times, but the negative remains on the outside of the negative 3 squared. Thus, our answer is negative 9. So as you can see, there's a big difference when there's a parentheses around the negative 3 and when there are no parentheses around the negative 3. Okay, let's do another example. Say we have 2 times 3 squared. 3 times 3 is 9. And 2 times 3 times 3 is 18. Thus, 2 times 3 squared is 18. There are several rules that go along with exponential expressions. So let's start off with the first rule. The first rule we'll talk about is called the product rule. The product rule for exponents. This rule says if we have two like bases, a to the m times a to the n, then what we do is we add the exponents together. Thus, a to the m times a to the n is equal to a to the m plus n. So let's do a couple of examples. Example 1, x squared plus x to the third would be equal to x to the 2 plus 3, which is equal to x to the 5th. Now, the second example is 3 times y to the third times 4y to the 5th. In this example, we multiply the two coefficients together. 3 times 4 is 12, and y to the third times y to the 5th is equal to y to the 3 plus 5, which is y to the 8th. Thus, our solution is 12y to the 8th power. The next rule is the power rule for exponents. The power rule states that if we have an exponential expression and it's also raised to a power, such as a to the m to the nth power, then we are to multiply the exponents together. So a to the m to the nth power is equal to a to the m times n. This rule can also be expanded to a product. So a times b to the nth power is equal to a to the nth power times b to the nth power. Let's do an example. X to the 5th to the second power, or x to the 5th squared, is equal to x to the 5 times 2, which equals to x to the 10th. Let's do an example using the product of a power. X, y to the second power to the fourth power is equal to x to the 1 times 4 times y to the 2 times 4, which equals to x to the 4th times y to the 8th. Oops. Now let's do the last example. 5x to the 3rd, y to the 2nd, z, all to the 3rd power. Well, this is equal to 5 to the 1 times 3, x to the 3 times 3, y to the 2 times 3, and z to the 1 times 3. When we multiply the exponents together, we simplify to 5 to the 3rd, x to the 9th, y to the 6th, z to the 3rd. And once we simplify 5 to the 3rd power, we get 125x to the 9th, y to the 6th, z to the 3rd as our final simplification for this exponential expression. Thank you for listening today.